Today we will learn Global Positioning System GPS. Objective: to plot a small area using GPS measurements. Theory: the Global Positioning System (GPS) is a satellite-based navigation and surveying system for determination of precise position and time using radio signals from the satellites in real time or in post-processing mode. The Now-Star Global Positioning System is a satellite-based navigation system being developed and maintained by the DoD since 1972 for providing extremely accurate 3D positions, fixed and UTC information to properly equipped users anywhere on or near the Earth at any time, regardless of weather conditions. The satellite continuously transmits dual-frequency navigation signals consisting of information of satellites' position with time tag, along with other data which is periodically uploaded in satellite memory from the control segment. The user segment receives navigation signals from at least 4 satellites available anytime globally, allowing the user to simultaneously solve 4 independent range difference equations to yield his position, latitude, longitude and height and also the time. GPS segments. The global positioning system basically consists of 3 segments: the space segment, the control segment and the user segment. 1. Space segment. The space segment contains 24 satellites in 12-hour near circular orbits at altitude of about 20,000 km with inclination of orbit 55 degrees. The constellation ensures at least 4 satellites in view from any point on the Earth at any time for 3D positioning and navigation on worldwide basis. The 3-axis controlled Earth-pointing satellites continuously transmit navigation and system data comprising predicted satellite imperages, clock error, etc. on dual frequency L1 and L2 bands. 2. Control segment. This has a master control station MCS, few monitor stations MS, and an upload station ULS. The MSs are transportable shelters with receivers and computers, all located in USA, which passively track satellites accumulating ranging data from navigation signals. This is transferred to MCS for processing by computer to provide best estimates of satellite position, velocity and clock drift relative to system time. The data thus processed generates refined information of gravity field influencing the satellite motion, solar pressure parameter, position clockwise, and electronic delay characteristics of ground stations and other observable system influences. Future navigation messages are generated from this and loaded into satellite memory once a day via ULS, which has a parabolic antenna, a transmitter and a computer. Thus, role of control segment is to estimate satellite, space vehicle, SP, ephemerides and atomic clock behavior, to predict SB position and clock drifts, to upload this data to SBS. 3. User segment. The user equipment consists of an antenna, a receiver, a data processor with software, and a control or display unit. The GPS receiver measures the pseudo range, phase, and other data using navigation signals from minimum 4 satellites and compute the 3D position, velocity, and system time. The position is in geocentric coordinate in the Basic Reference Coordinate System, World Geodetic Reference System 1984, WGS84, which are converted and displayed as geographic, UTM grid or any other type of coordinates. Corrections like delay due to ionospheric and tropospheric refraction, clock errors etc. are also computed and applied by the user equipment or processing software. Through this fieldwork, a student will learn about taking data using a GPS receiver and using that data to plot surveyed areas as well as make other calculations including area of that place. Surveying surveyors are responsible for mapping and measuring features on the Earth's surface and underwater with high accuracy. This includes things like determining land boundaries, monitoring changes in shape of a structure or mapping the sea flow. Surveyors have historically required line of sight between their instruments in order to undertake such work, but the availability of high accuracy GPS receivers has reduced the need for this. GPS can either be set up over a single point to establish a reference marker, or it can be used in moving configuration to map out the boundaries of various features. This data can then be transferred into mapping software to create very quick and detailed maps for customers. Instruments: 1. Antenna and cables. 2. Batteries and power cables. 3. Tripods, tri-branch and adapters. 4. Tape measures. 5. Flashlights. 6. Radios. 7. Station log sheets. 8. Writing apparatus pens. 9. Station descriptions. 10th. Observing schedule and station list. 11. Special equipment required. 12. Traffic cones safety equipment. 13. Maps, keys, log combinations. Procedure: 1. Reconnaissance for a GPS survey. 2. Antenna is set up. Check that tripod is stable. Weights such as sandbags must be used to stabilize legs on hard paving surfaces. Check that antenna or tri-branch is level. 3. Keep signal path clear. Heads, trucks, etc. Check for reflective objects. Example, any nearby vehicles. 4. Orient the face center offset. 5. Follow the manufacturer's recommended procedure for determining the antenna height. Make at least 2 antenna height measurements per session. Verify the height at the end of station occupation. Measure the antenna height in meters and preferably in feet as well. 6. Operate the receiver following the instructions of the instructor. 7. Initialize the session according to the requirements of the survey method utilized. 8. Key in all necessary station and station related information. 9. Coordinate the length of the session with other stations. 10th. If other stations are not ready, you may start observing early. 11. Check receiver and antenna frequently during observations. Check for power loss, tripod movement, etc. Record weather data and note any drastic changes during sessions. Monitor data logs and note unusual occurrence during sessions. Reconnaissance for a GPS survey. Reconnaissance is one of the most important parts of a GPS survey. For the actual collection of GPS data, the observing station must have a clear view of the sky when satellites are passing over the job sites. Steps involved in a typical GPS reconnaissance include: A. Mark the general area where GPS control points are to be located on maps or aerial photographs. B. Visit the job site and select the best location for the control point. C. Using a station visibility diagram, locate and record all obstruction exceed 20 degrees above the horizon as well as any radio frequency RF sources. Ideal tools for this are a compass and Avni level. D. Using the station visibility diagrams and a sky plot of visible satellites at the time the GPS survey is to take place, the proper observing session can be planned for each station. Methodology: Point positioning. In point positioning, coordinates of an antenna position at an unknown point are sought with respect to the WGS84 reference frame. In this method, the known position of the tracked GPS satellites, the position of a satellite can be computed from ephemerides are being used to determine the position of unknown point using single GPS receiver by a method similar to the method of rejection used in plane table surveying. Figure 10.1 shows you point positioning of GPS receiver. In this figure, S1, S2, S3 and S4 represent 4 different satellites, least required, being tracked. The positions of these satellites are referenced to the center of Earth in the XYZ coordinate frame. The coordinates for S1 are shown as XS1, YS1, ZS1. The coordinates of R, the known point, as reference to the center of the Earth are assumed to be XR, YR, ZR. The observed code PRS1 relates the known coordinate of satellite 1 with the unknown coordinates of the receiver using the equation for a line in 3-dimensional space. That is, thus from 4 satellites, Four distance equation can be formed leading to computation of the four unknowns. XR, YR, ZR and clock base can be computed. Control point. Land surveyor measure horizontal position in geographic or plane coordinate system relative to previously surveyed position called control points. Control points are those whose position and coordinates are already known before start of survey. A geodetic control network consists of stable, identifiable points with published datum values derived from observation that tie the points together. The control point is used to enable to plot a map based on GPS data. Good site characteristics of a control point for GPS observation include a clear view of the sky. Next, no obstructions above the cut-off angle, say 15 degree. Next, no reflecting surfaces that could cause multipath. Next, safe away from traffic and passers-by. Next, possibility to leave the receiver unattended. Next, no powerful transmitters, radio, TV antennas, etc. in the vicinity. Assignments. Plot the interior details of the area surveyed in a drawing sheet. Find the area of the plot. Compare it with manual measurements taken with a tape or chain.